Well, I hope that first section in Chapter 11 went well for you. And again, that was mostly on vocabulary. We're going to review a little bit of the vocabulary at the start of this. But this second section will be on central angles and arc measures. So we talked about what an arc was. It's a part of a circle. It's the curved part of the circle. There were three types: minor arcs, major arcs, and semicircles. Minor arcs being less than 180 degrees, and they were less than half a circle. Major arcs being more than 180 degrees, more than half a circle. And semicircles being exactly 180 degrees, exactly half a circle. And minor arcs had to be named with 2 letters using an arc symbol. Both major arcs and semicircles named with 3 letters. Okay, so let's take a look at some review of the vocabulary here. In this one, we have a diagram over there. We have a green segment, a red segment, a kind of pink segment, and a purple segment over there. This one's asking us for a line. It says line CD. So that would be a line that goes through 2 points on a circle and it passes through it. Because it's a line, that would be called a secant. So that one is a secant. The next one is a segment. This one is a segment. And both A and B are on the circle itself. So if we're looking for segment AB, that would be a chord. The next one has an arc symbol. That's what that curve on the top means. It goes from B through C to M. So that one would go from here all the way around to here. Well, we can see that that's clearly more than 180, more than half of a circle. So that would be called a major arc. The next one, well, this one we can see is an angle. And the angle X to D to C. X to D to C. Well, we can see that that's an angle that has its vertex on the circle itself. So that would be called an inscribed angle. M. Well, M is just a point, and it's the point where that purple segment just touches the circle. So that would be called a point of tangency. The next one here, well, that next one looks like it's an arc again. And it's the arc from C to X. Definitely less than 180. So that's going to be a minor arc. A little bit of a review of vocabulary, and again, your first assessment in this chapter will likely be almost completely on vocabulary. It may have a little bit of this section that we're beginning today on it, which is arcs and central angles, so you'll want to prepare for that and make sure you know what your teacher expects. So let's move on to arcs and central angles. Once again, a central angle is an angle that has its vertex at the center of the circle, and the sides will be radii. Now, the degree of an arc is equal to the degree of its central angle. So if I'm looking for this arc out here, A to C, that's going to be 82 degrees. And then since a full circle is 360 degrees, I can subtract 82 degrees from that, and I end up with 278 degrees. Okay, so once again, the central angle equals the arc measure. Both are in degrees. And that's what this section is about. Let's take a look at a few more examples. Now, we do have a pair of vertical angles here. And we know vertical angles are congruent. So that means that this one is 21 degrees. I can take 180 minus 21, and I get 159 degrees. So that means that this angle right here is 159 degrees. Likewise, this one's 159 degrees. Now let's fill in some answers. The arc JK. Well, the arc JK is going to be 21 degrees. Sorry about that. The angle JNM. JNM. J to N to M. Well, that's 159 degrees. I have that one labeled. Arc KL. Arc KL, 159 degrees. The measure, and these M's in front mean measure. The measure of arc JKM, J to K to M. J to K to M would actually start here, go all the way around to there. Now, that's more than half of a circle. I think I would have to take 180 plus 21. So that would be 201 degrees. J to K to M. M to K to L. Well, M to K to L is almost the whole circle. M to K to L would be the whole circle minus the 21 degrees. So 360 minus 21. 339. So we use our whole knowledge to fill in all of these. Let's try another one. We have several examples today. Okay, let's just see what we know here. Well, we do have vertical angles again. Vertical angles are congruent. So that would tell us that this one's 72 degrees, this one's 72 degrees, this arc's 72 degrees. And then we can take 180 minus 72 equals 108. So that means this one is 108 degrees. We can take 180 minus 72 minus 87. We get 21 degrees. So this one up here is 21 degrees. That means this is 21 degrees. This one's 108 degrees. This one's 87 degrees. Now let's see if we can fill in what we were asked to find. The measure of angle UXV. UXV. Okay, that one we had right from the beginning. 72 degrees. U to X to V. Arc S to T. That one was 21 degrees. The measure of arc W to V. Yep, got that one. That one's 108 degrees. The measure of arc T through V to W. Now, we don't have that one yet. T through V to W. So the measure of arc TVW, oops, got to put my arc symbol on the top. That's going to equal 87 plus 72 plus 108. 87, 72 plus 108. 267. And arc T to W. Measure of arc TW. Okay, TW, 21 plus 72. So 93. Now I'm going to continue the rest of these examples, but you see what we're doing here. In each of the previous problems, we tried to fill in everything that we knew. So let's fill in everything else we know. So this one is 90 degrees. That means this arc out here is 90 degrees. And that would mean that this one over here is going to have to also be 90 degrees because we have a diameter. This one's a diameter. Okay. And then we can take 90 degrees minus 34 degrees equals 56 degrees. And that would be this one, because I know that's a right angle right there. So that's 56 degrees. This one over here would be 34 degrees. And this one would be 90 degrees. So this is 90 degrees as well. And I like to label everything I can first in the diagram and then check to see what they ask for. So they asked me for the arc C to D. That was the first one we got. That's 90 degrees. They asked me for the arc from F to D. For F to D, I'm going to have to take 34 plus 90. 34 plus 90, 124. Okay. D to C to F. D through C to F. 90 plus 90 plus 56. $236. G to D to F. G through D to F. Well, that's almost a full circle. 360 minus 56. G through D to F. 304. Okay, and again, I have several of these examples. If you don't want to watch the whole thing, you certainly don't have to. So let's see what we got here. We know this one over here is 90, so this is 90. Let's see, this one would be 19 because we have vertical angles. Here are our vertical angles again. I can take 90 minus 19, and I get 71. So that means this one up here is 71 degrees. I can take 180 minus 19 and get 161. So that's this one right here. Okay, now let's see if we can fill in what they asked us for. The arc P to Q, we had that one almost right away. The arc S to R, that one's the 161. The arc Q to R to T, okay, QRT. Well, QRT is going to be 180 plus 19. It's really 19 plus 161 plus 19. $199. PSR, P through S to R. PSR would be, 90 plus 19 plus S to R, 161. 90 plus 19 plus 161. 270. And P to S. P to S would just be 90 plus 19. Okay. Sorry about all the bigger and smaller that's happening here. It's just me having trouble with the iPad. Now, this next one is a little bit more involved because it actually has variables there. But we do have a diameter. So since we have a diameter, this being a diameter right here, we do know that this whole thing right there, 180 degrees. So I have 15x minus 26 plus 26 equals 180 degrees. So that really gives me 15x equals 180 degrees. 180 divided by 15, x equals 12. And it's because of the diameter that we had there. Number 6. Once again, we have variables involved. And when I look here, I can figure out this arc right here by taking 180 minus 103. So 77. So this would be 77 degrees. This one's 77 degrees. We have vertical angles right here. Since we have vertical angles, this one over here is 77 degrees. So this is 77 degrees right there. And now let's just go ahead and work on this side right on over here. So that's going to be a semicircle. That means if I take the 18x minus 2, I add the 15, and I add the 77, I'll get 180 degrees. Because that's half of a circle, 180 degrees. Combining like terms, negative 2 plus 15 plus 77, I get 90. So 18x plus 90 equals 180. Subtract 90, 18x equals 90. 90 divided by 18, I get 5. Another one. Vertical angles again. So these will be congruent arcs. So that means 8x plus 12 will equal 10x minus 22. I'm going to subtract 8x on both sides. I get 12 equals 2x minus 22. I'll add 22 and I get 34 equals 2x. So each x is 17. The arc from A to D is going to be 8 times 17 plus 12. $148. The arc from C to D that's going to be 180 minus 48. Nope, sorry about that. Nope. That's going to be 180 minus 148. So 32. And the arc B through D to C. Now, that's kind of a big arc. From B through D to C would go here. That's going to be a full circle minus this 148 out here. So the measure of arc BDC will be 360 minus the 148. 212. Okay, a couple more here. Actually, 3 more. So let's see what we have. Well, looks like we have a diameter. And since we have a diameter, we know that this whole thing here is 180. So the 5x plus 23 plus the 17x minus 41 will equal 180. Combining like terms, I have 22x, negative 41 plus 23 gives me negative 18. I'll add 18 to both sides. And I have 22x equals 198. I divide by 22. Each x is 9. So I now know the x. For the measure of arc JK, it's going to be 5 times 9 plus 23. 5 times 9 plus 23. It's out to be 68. Measure of arc MJ. That's going to be 180 minus 68. 112. The measure of arc LMK. LMK. So that's all of that. Well, I already know that this is 112 because it's vertical to this one. So the measure of arc LMK will be a full circle minus 112. 360 minus 112. 248. Okay, 2 more examples. And again, feel free to stop this video and go on to whatever you need to once you feel like you understand it. So we do have vertical angles again. Here are our vertical angles. Because we have vertical angles, I know that this one will be 31 degrees. I know I can take 180 minus 31, and I get 149 degrees. So this one's 149 degrees. That would make this one 149 degrees. And that would allow me to solve 9x plus 23 equals 149. I'll subtract the 23. 149 minus 23, 126. Divided by 9, I get 14. That was a lot shorter one. One last example here. Okay. Well, I have a diameter. So probably the most straightforward way to set that up is to know that all of this would be 180 degrees. So that means if I take 12x minus 5 plus x minus 3, it will equal 180 degrees. So 13x minus 8 equals 180. 13x equals 188. X equals... Uh-oh. Let me start that one over here. Because it's not 5, it's 25, isn't it? So 12x minus 25. So now we have 13x minus 28 equals 180. So 13x equals 208. So x equals 16. And then once you have your x, you can find anything else you really need. So the arc from D to E. Well, first let's find the arc from E to F. The arc from E to F is going to be 16 minus 3. So that one's just 13 degrees. Now for that arc D to E. The measure of arc D to E, well, that's going to be congruent to arc G to F. So that will be 12 times 16 minus 25. 12 times 16 minus 25, 167. Now I could have gotten that in a different way. I could have just taken 180 minus 13. That would have worked as well. And the measure of arc DFG, DFG, well again, that's almost an entire circle. So DFG is going to be 360 minus D to F to G. Minus 13. 360 minus 13, 347. Okay. And that should be enough.